Once again, my apologies to the complete audience that due to this my inability, I wasted about 5 minutes or so. Anyhow, now we come to there are four key climate change indicators. Yesterday news only that they found that there is change in the greenhouse concentration, sea level, rise, ocean heat, and oceanic acidification. These four parameters of climate change, which will have set new records in 2021. Not only that, ladies and gentlemen, I must put on record from where I am talking to you and presenting this New Delhi. It has beaten 122 years of record of the highest temperatures recorded in some other places, 49.8, 49.2 degrees Celsius. So this is the state, and we are under the hot wave conditions from last week or so, and obviously the death has taken place. And so no, this all these things are creating the drought position. And about a week back, when we were in the position to give the wheat to all over the world export during this crisis of Russian-Ukraine war, now we have to shrink a little bit because the production has been affected with these droughts due to hot waves of the thing. So why I'm telling you this example, that how effective these climate parameters are there, and due to this climate change, your global warming, and what is the rise of temperatures in the complete environment, as you all know, due to the greenhouse gases, particularly, and other fossil fuels, which you all known to you, create the air pollution and vis-a-vis water pollution as well, which is caused to toxic things, which we'll talk in detail. And here I would like to tell you that this air pollution was defined in the olden Vedas of Atharva Veda, that is about 5,000 years old, world's oldest epics, that whenever the balance of air, water, and energy, this balance gets disturbed, the environment gets polluted. That means the air pollution takes place, the droughts take place, tsunami, cyclostorm, pralay, all the balance when it's withdrawn the nature, then all the disasters, natural disasters take place. And you'll be surprised that in Atharva Veda, one of there are four basic Vedas, and in that 10, 2, 13, and 431, the breathing process has been explained. You must wondering, about 6,000 feet, 6,000 feet years or so, the great scientists of the Indian origin, they knew about this breathing process. In 24 hours, one person inhales 40,000 cc of oxygen and exhales 40 kg of carbon dioxide. Of course, this nomenclature of gases was in Sanskrit, which has got the English translation, which I put it here. One person can pollute, this is now out of that purview, the one person can pollute a room size of 9 feet by 10 feet, 10 feet air of 900 cc in 15 minutes. A person generates 500 gram waste per day. So these are the alarming figures which pollute your environment, and which consists air pollution as well as your water pollution. Now, air pollution is very significant, as you know. They are the air pollutants like sulfur dioxide, nitrogen oxide, greenhouse gases, that is methane, and your carbon dioxide, and the various respiratory elements are due to this. Central Pollution Board of India, that's why they have already, some of the places have been planned, or some of the places they are planning to put the water treatment process plants, so that the water pollution is the main cause of waterborne diseases. And your TC is an indicator of water quality, as you all know. TC includes your fecal coliform bacteria, that is derattled strain of E. coli found in the intestines of warm-blooded animals. Well, we have got the one of the highest institute, or the biggest institute in India, that is All India Institute of Medical Sciences, which is an autonomic body and does a lot of research in medical sciences. They have reports that this report is of last year only. The antibiotics, painkillers, and other leftover medicine thrown in the water bodies directly or indirectly through the garbage come back to us in milk, vegetables, and other agriculture produce, and also give rise to your actually super bugs. Those are the soup X they call it. The most antibiotics that can which cannot be killed. You see, the concentration of dissolved drugs also increase your water pollution. Like we have got Yamuna River here, and in that they have found that there was 121 times of increase of diclofenac, that is a painkiller, in the water, and 96 times increase in the afloxacin, that is another antibiotics. So this is the, I mean, the alarming result. And not only that, this industrial water which is going, it is creating the chromium in that, I mean, the industrial waste which is going into the rivers, unfortunately, that also creating the chromium in the water, and that causes the other type of diseases, even resulting to the cancer. Now we will come very quickly to the your chemical contaminants. What are the chemical contaminants which pollute the water? There are 8 types of chemical contaminants. One is your non-halogenate voltaic organic compounds, halogenate voltaic organic compound, non-halogenate semi-voltaic organic compound, halogenated semi-voltaic organic compounds, and after this your 4, then it comes another 4. Fuels are there, inorganics contaminants are there, radionuclides are there, explosives are there. So these are all things that you might have seen. All the nuclear tests mostly done in the deserts or in the water. Unfortunately, that is another reason of contaminating of the water, getting contaminated with the toxic elements. The contaminated water not only give rise to the waterborne diseases, also results climate change in altering our environment, which I told you right in the beginning. This affects your agriculture, this affects your water availability, sea level, is increasing the intensity of natural disasters like tsunami, cyclone storm, droughts, floods. And I must another give you the example in our northeast part of India, that is the Assam region, or Meghalaya, all these places, we are under very heavy floods, and a lot of bridges have been just destroyed, and water has gone into the houses of the people, and very bad states. Rescue operations are on, a lot of lives have gone, and same business southern state of Karnataka today. So I mean, we are the people who get affected with all type of climates, all type of weather, and with all type of disasters. Well, life is like that. The too much water causes your river banking erosion, and the less water causes your water channelization, dams, and other things ought to be done for this. Another remediation of, I mean, the water management should be done by creating the river water channelization. If we do the river water channelization, we are sure that we can, to some extent, we can control these floods, and also same by dams, apart from creating electricity or hydroelectricity, what you call it. The other is the rise of sea level due to global warming or the climate change. Now let's come to the objective of this particular research. We aim to develop a physiochemical and spectroscopy method in the situ chemical speciation of inorganic contaminant technologies for remediation of water polluted by catalytic, oxide, and transitional areas. See, it reminds me one of my lecture when in 2016, I was invited by NASA, and I was giving a lecture on the models of the control of the global warming. So one question was, there no doubt the plantation is one of the best way to control the global warming, but can we wait 10 years to grow the plant? No, we have to find out the mainly chemical processes to control the pollution. Maybe a air pollution, maybe a water pollution, maybe any kind of pollution for that matter. So the other objective, so that's why this study was taking to basis on purely chemical innovation to control the water pollution. The oxidation process will be employed to treat groundwater, making use of physiochemical properties of this catalytic oxidant involving in subsurface system and groundwater system by regeneration of granular activated carbon and using the high affinity toxin receptors to entrap toxin gases as well as innovative catalytic processes to convert your greenhouse gases, methane and CO2, to ethanol and further your oxidation reactions uh, to other chemicals into non-toxic chemical. Next, to control marine pollution over oceanic transition areas, the study explored multiple stresses on ocean, sea level variability, mechanism, sub-mechanisms by the comprehensive studies of ocean systems interactions, risk instability. In short, we call it OSIRIS. Also, we have done some of most of the work had been done, and some is in the pipeline to investigate the aquifer materials target and non-target contaminant treatment process and their correlation with climate variability. Finally, efforts are to develop correlation predictive model of chemical reaction kinetics in order to process fundamental and assess contaminant transformation over the areas of strong gradients, that is TA areas, what we have taken the area of interest in the physical environment associated with the oceanic transition areas. So this is the objective of this study. The attack is quite it's a multi-directional attack. The problem is being taken from 2 or 3 types of orientation. It also aims to understand the air-sea exchange during extreme atmosphere, correlate air-sea. I think you are my auto. You have put my things and things are going very fast. Anyhow, next, through sea level oriented forecasting models we have to develop, and for that we have to study mesoscale convective system, global carbon cycle, ocean salinity, and marine pollution. Now, the background of this work, which I told you, researchers have found that sea level rise was due to the carbon dioxide and other greenhouse gases as opposed to the other type of forces. Hence, it's imperative to analyze satellite imageries, which we have that infrared and visible regions, and then find out because why the satellite imageries? Because on the oceanic region where the data paucity is there, we should be able to do. In May 17, Professor Pere Breve had devised a water filtration system which combines microbes and gravity using ultrafiltration membranes, which is very fine screen that removes not just particulate matter but also large molecules, disinfectants, herbicides, pesticides, contaminants from water, that is microbial pathogens, viruses, and bacteria. And this is what 70 is, and also the bloodstream increase the risk of heart attack and strokes due to this polluted water when it takes. As per the State of Global Air 2017 report released in Boston, about 2.54 lakhs deaths occurred in 2020 on account of exposure to ozone and its effects on chronic lung diseases. Now quickly we go to the next one. Okay. Now the other, as I told you, that you cannot just have the, the partition, that you cannot say that northern hemisphere cyclonic storm have got no effect on the southern hemisphere. That's why the teleconnection from northern hemisphere and southern hemisphere, WBCTAs was studied, and lately on May 21, the Climate Tropical Pacific Observing Needs to Advance Policy Understanding and Models workshop was held to discuss on top Pacific observing needs to understand multi-scale ocean atmosphere, coupled processes, geochemical models, and all these things. There are generally 2 types of pollutants we are talking of for environment pollution. One, CO2 absorption by the sea, carbonic acid, which leads to the fall in pH, soft corals of reef environment. The slower dynamics of the ocean mean that some changes that such as ocean acidification will be taking place. And these are the toxins in the water, that is chemical toxins, physical toxins, biological radiation, and water gets polluted due to particulate matter, disinfectants, herbicides, pesticides, and contaminants from water, that is microbial pathogens or viruses. and bacteria. Water also got polluted due to microplastics. Microplastics, they have penetrated in the tap water in the countries across the world. Microplastics brought toxic chemicals linked to illness when consumed by fish and mammals. Microfibers might originate in the everyday clothing of story carpets, and the other water contaminants are your microbial pathogens, varicose bacteria, herbicides, and pesticides. So these, after having known what are the water pollutant, now this is the sources of plastic waste, which you can see by chips of your confectionery bags and your milk bottles, cigarette lighter, I think with the plastic which you are doing and which is non-gradable plastic that is creating the plastic water. Now, the question comes how to get rid of remediation of water and plastic pollution. We have to develop inorganic method which can remove your inorganic toxicants or inorganic toxins, that is your mercury, hydrofluoric acid, chlorine. And also we have found an organic one, and then plastic can be used for the making the plastic rolls by mixing with the bitumen, and that the figure has been, the process has been shown how this plastic waste can be used. And now the oxidation process system is a groundwater treatment system involving chemical oxidation of GAC to treat groundwater contaminant. The second method is entrapped chemical oxidant, that is lead, mercury, hydrofluoric acid, by using HART, that is high affinity toxin receptors. And then third method is physiochemical and spectroscopy method, which we have tried at Indian Institute of Technology, Kharagpur, and removing the your hydrogen peroxide, persulfate, permanganate, and ozone from the water. And this was investigated the process fundamental, and we also studied the chemical reaction kinetics. When the oxidation reaction takes place, what is the chemical reaction kinetics? And then this was the results were analyzed by chromatography, liquid chromatography, as well as the solid chromatography in case of your inorganic one. And this was found that before remediation of the water pollution, there were a lot of difference between the chromatography measurement than that of the pure water. And these reaction kinetics were studies under high pressure as well as the low pressure by using the first row of transitional metal oxides, that is your cobalt oxides, CO2, 3, CO1, CO2, because all these three have got the different your atomic structures. And it was found that the catalyst, those oxides or the first two transitional metal oxides in the periodic table you all know, and it's particularly this cobalt oxide, if you see, then 3D7 structure is more catalytic activity than having 3D6, etc. So they are the water treatment processes, and I will come to that. It has been observed that matching the oxygen and in situ delivery system to the contaminant concern, their COCS and the site condition is key to successful implementation and achieving best results in the water treatment process. So that is what we want to say. The water treatment process is the main thing by using the catalytic chemical oxidants, in particular the first row transitional metal oxide. Now, there's another study was also done. The correlation of their physical properties with the chemical or catalytic activity was studied. Instead of wasting a lot of time and chemicals of just trying hit and trial what should be done, these physical properties were studied to find out what is the dehydrogenation reaction and what is the hydrogenation reaction and how the chemical kinetics or the reaction kinetics get effects. Now, general mathematical water treatment processes are, the physical processes are there, chemical remediation water treatment. Naturally, physical processes are known as PRT and chemical remediation technology known as CRT. The physical remediation technology involves the use of physical properties of the contaminants and the separation of contamination. And the contaminated medium is destroyed by chemically converting. It may use chemical oxygen and catalytic oxygen, which I mentioned to you, to either separate the contaminants or destroy the contamination. Passive treatments wall separate and destroy the contaminant in situ groundwater by PRT are economical than CRTs. In the CRT, that is chemical oxidation, due attention be paid to the reaction chemistry and transport processes and management of remediation of waste. This is very important aspect. Otherwise, sometime when you're working with the high pressure reactors, even the explosion can take place. So one has to be very, very careful. And when you're working with a different environment, these reactions and on the different gases environment, you have to be very careful on this. This investigation intends to employ the PRT and CRT as regards groundwater, sewage water, and your leachates, that is air sparging and bios. These are the chemical processes for the water treatment, and reactional wells and dual phase extraction, thermal treatment, and hydrofracturing. In air well stripping, passive reaction treatment walls. This all we worked in chemical technology during doctor and postdoctoral program, and there we developed some of the equipments as well. The rate and extent of degradation of target are dictated by the properties of the chemical itself and its susceptibility to oxidation degradation. That's very, very important. And this, sorry, this, what happened? Something gone wrong.
And just see where your presentation is.
Okay, okay.
Right one, right one.
Okay. Is it okay now?
Yeah, we can view now.
Okay, thank you very much for your cooperation. Okay, the next one. Okay, the other, now we come on the metric conditions. What are the matching conditions for these water treatment processes? That is pH, temperature, the concentrated oxidant, and the concentration of other oxidant consuming substances. There is organic matter, reduced minerals, carbon, and other free radical squenches. In these processes, oxidant delivery system often employed vertical horizontal injection wells and sparge points with the force advection to rapidly move the oxidant into the subsurface. You see, this I need not to explain. Even when you go to the oceanic sciences, you find the subsurface regions, deep water region, all these things, deep layers. And so this is what subject you all are expert in that. So I'm not going to detain. Then ozone oxidation process is very important. This oxidizes contaminant directly or through the formation of hydroxyl radicals, that is peroxides. These reactions are most effective in systems with acidic pH. Ozone oxygen reactions proceeds with extremely first order kinetics. You know, there are first order kinetics, second order kinetics, and due to ozone high reactivity and instability, ozone is produced on site and it requires closely spaced delivery points, is air sparging wells, because it's very unstable gas. This is not a like oxygen, you can just put in the cylinders and other things. This is very high reactive gas. And so there's a composition of ozone can lead to the beneficial oxidation and biostimulation. Then the other is a peroxide oxidation, that is the Fenton reagent oxidation. This process using liquid hydrogen peroxide in the presence of native or supplemental ferrous iron oxide produces Fenton reagents which yields free hydroxyl radicals. So this is another process. These strong non-specific oxidants can rapidly degrade a variety of organic compounds. We talked in the beginning in organic contaminant and the organic contaminant when we're talking about the 8 types of water contaminants. Fenton's reagents oxidation is most effective under very acidic conditions. That is when 2 to 4 is the pH, and it becomes ineffective under modern or strongly alkaline conditions. The reactions are extremely rapid and follow second order kinetics. In this Fenton, this is for the organic pollutant, and earlier which I described were the inorganic pollutants. Now, well, gentlemen, this is little my own work, which I catalytic oxides of first transitional metal oxide, cobalt oxide, should optimize the process of subsurface remediation, and above ground water treatment system, depending on a variety of site-specific conditions that is reaction rate kinetics. This was the study I did it, and we found the correlation with the catalytic activity, reaction kinetics, surface area, chemical absorption, measurement, and their differential thermal analysis we did, gravimetric thermal analysis we did. Even we went to the electron microscopic studies and X-ray diffraction. And when that time we didn't have your ESR or NMR in India. So in Illinois, when we went 84, I worked. So there we studied into that there also. Hence, efforts are focused to discuss strategies to save underwater marine life and environment by controlling water and environmental pollution resulting due to toxin, chemical, biological, physical, and radiation. Radiation, same which I talked in the beginning, this all the nuclear tests which are being done in the oceans and the water, this all radiation are being in the water. So that to be also rectified or rather removed. And the toxin gases also by catalytic oxides of first row transitional oxide and improving high affinity toxin receptor. This hard to be modified, that what we feel we didn't have time to do that at that time. So however, this one youngsters can try to modify this high affinity toxin reaction, and that is CHO4, CH2, N2, CFC, that is chlorofluorocarbons, which is the main you use in your air conditioning and refrigerations, converting CH4 to methanol, sorry, my fault, from ethanol by catalytic process and developing hybrid fuels like bioethanol, biodiesels, and go for electricity from biomass as well as bioremediation. Next to evaluation, correlation of chemical oxygen with chemical species associated with soil and aqua material and with target and non-target contaminant during water treatment process. Because it's going to be my 40 minutes or 45, so still I have got 5 minutes left with you. So I'm not explaining the detail of these processes which have been done mostly. Next to chemical oxidant with chemical process associated with soil and aquifer material. This was also studied, and with this was studied in the soil laboratory by one of our colleagues, Dr. Sinha, and with target and non-target contaminant during water treatment process. But to develop physiochemical and spectroscopy method characterize the situ chemical speciation of the non-contaminant to entail water contaminant toxic and develop. We have used catalyst absorption beds. We use carbon sinks. We use cobalt oxide catalyst converters. This we already developed. This was not there, gentlemen, for limiting greenhouse gases, CO2, CH4, CO, H2, N2, SF6, and your 14 CO2, and inhibit the generation and widespread release of the chemical substance in the water bodies, and optimize the remediation of water treatment process by chemical oxidation and regeneration of general active carbon to save marine life. Ladies and gentlemen, I must tell you that some of the reaction process under high pressure continuously for 76 hours or so. Finally, to develop coefficient predict models, we developed that model of reaction kinetics model. And now we are just going to the end, and then as I shown you, we studied these transition metals and the mitigation emission of carbon dioxide. Of course, we all know plantation and your anthropogenic activities, methane to ethane, wind, water, solar energy, green energy. These are some of the processes which are well known for this to control global warming. And what one more brainchild has come to my mind, which I've sent my research proposal also to NASA recently, that the lunar cooling should be studied. I'm in the view that lunar energy can be harnessed and used for cooling and production of lunar ACs and refrigeration as well. Lunar cooling can be generated by either harnessing the lunar energies through lunar panels like solar panels or develop the lunar concentrator. Well, this is the idea or hypothesis thrown in your quote to work upon that. The remediation of water contaminant treatment and detoxification of toxins may be used to develop this model of chemical reaction kinetics. Of course, I wish I get the opportunity to go back to my alma mater NASA and work on this lunar cooling. Lunar cooling. Now, the general method procedure in the sea level viability forecasting models also we have developed in order to study the interaction of oceanic atmosphere dynamics and thermodynamics affecting the regional air-sea exchange process and the large-scale interaction with the air-to-sea carbon dioxide flux in the oceanic region, which we also studied. And in order to coordinate some missions called dynamics, oceanic, physical, chemical, bio-oceanic process through the computation of sea level variability, some missions chemistry by developing this ocean system interaction stability, and OTAS was also done to study the also kinetic features of the mesoscale convective systems were studies to bring out the optimum value of these sea surface temperatures and to investigate what is their effect on the air-sea carbon dioxide fluxes, biological activity, and energetic in correlation with the dynamic fluid, and steps to develop your numerical models. We are now trying to develop the numerical model of sea level variability of forecasting models by using the grid of 1 degree by 1 degree and then following the McIDIS man-computer interaction data access system, and then also studying your mean velocity, divergence, and wind co-measurements as regards your severe weather phenomena. And 3 to 6 hour sounding have been taken. The introduction of surface sounding, and later we have also some disturbed phases we have gone. And finally, we came to this physiochemic spectrum methods which is used to characterize city chemical speciation, pollution by catalytic oxidant, and the process of initiation, computation, parameterization with the 1 by 1 degree grid blocks by the computer algorithm was employed in order to develop numerical sea level forecasting using the satellite fitted with lightning sensor tube sets. And this again is not complete yet. It is being studied, and we are sure to develop the model. And this for the latest interest, as you all know, car has been developed now, which run on water energy, and then also the low clouds are being trapped to produce the water. Also the water ATMs, Bharat Heavy Electronics has developed in India, and it's very useful for our troops on the border areas, and tea plantation drones developed by Biocarbon Engineering Australia. Zero mass water. The zero mass water is nothing, is the name of US firm which uses the technology harvest drinking water out of thin air in Dubai region. They have done this thing, and with this scope, SLV can be improved through numerical weather prediction technology using mathematical models of the atmosphere ocean to proceed the weather based on current weather conditions by producing realistic results through the initiation, computation, parameterization with 1 degree grid blocks by the computer algorithm. This solves, ladies and gentlemen, and I think I put my 40 minutes to end. And thank you very much for your questions, sharing. And if any question is there, I will try to answer.